Welcome to Carlton's Math Corner. Today we are going to be talking about the area of parallelograms, triangles, and trapezoids. At this time, please make sure that you are ready to learn. You got your math journal, a positive attitude, and your vocabulary packet. Our first target today is, our target today is I can calculate the area of a parallelogram, triangle, and trapezoid. And we're going to start off with a parallelogram. First of all, we need to talk about what is a parallelogram. And many of you recall this figure from elementary school. A parallelogram, which I absolutely love this word, just to say this word, it's just a cool word, parallelogram. It is a four-sided figure, and we call it a quadrilateral because it's got four sides. And this quadrilateral has four sides that have two sides that are equal to each other, and they are parallel to each other. And notice, parallel basically just means that they will never touch. They're exactly at the same angle, and so they will never run into each other. And so that's what makes them parallel. And the word parallelogram has that word parallel in it. And so we have two pairs of parallel sides, and that's what makes it a parallelogram. Now, other figures that are parallelograms are like a rectangle. That is considered a parallelogram because it has two pairs of parallel sides. And it also has two pairs of equal sides. Now, a square is also a parallelogram because of the fact that it too has two pairs of parallel sides and two pairs of equal sides. And I know all sides are equal on a square, but it still fits the category of what a parallelogram needs to have, and that's just it needs to have two pairs of equal sides, and it does. And it's got two pairs of parallel sides. So these two are also parallelograms. Now what we're going to do first of all is we are going to find the area of a parallelogram. Now a parallelogram, if you notice, it's kind of tilted to its side. Okay? And when we just found the area of a rectangle, and remember that the area of a rectangle is finding the surface inside the figure. And so same thing, we're going to do the same thing. We're going to find the surface inside the parallelogram. Okay? And so a parallelogram does not have 90-degree angles. And so because that is true, we have to find a 90-degree angle inside the figure. And so do you see this dotted line? This dotted line actually is showing us that we started at one point, or we call that a vertex. We started at one vertex and went all the way down, straight down, and notice it creates a 90-degree angle. Now, since we found this 90-degree angle, that is considered our height. Our height is like the longest part of a parallelogram. Our height can be shown like this, or it can also be shown over on the side here. Oops, let me show you. Let me get a line, and I want a dotted line. And so like this could also be height right here. Notice if I start at one point and drop all the way down, this could also be the height of a parallelogram. So it can be shown over here, or it could be shown over here. And notice it's kind of starting to make a rectangle. Like look at the rectangular shape. If I connect these, it would create a rectangle. And actually, a parallelogram is basically taking this triangle. Do you see the whole rectangle now? Let me highlight it. Okay, so do you see this whole rectangle part? If I can get a straight line, oh my gosh, it's so hard. It's hard to get a straight line. But do you see this rectangle right here? Okay, so a parallelogram is basically taking and cutting the whole like this endpoint off, like cutting it off, making a triangle, and putting it over here on the other side. So just keep in mind that we need to have a height of a parallelogram. The diagonal part is never considered the height. Okay, it cannot be considered the height because it's not straight up and down. It's not it's not the highest part of our parallelogram. Okay, now let's look at this equation. It says to find the area of a parallelogram, we're going to take the base. That's what B stands for, is base. The base is basically one flat side of a parallelogram. And let me erase all this. Okay? And so our base is one flat side. It could be this side or it could be the other side that's parallel to it because they're both equal. So it really doesn't matter which side it is. It is not a diagonal, okay? It has to be one of the flat, straight sides, okay? And so, and I meant to say any straight side of a parallelogram, okay? So we're going to do base times height. Notice they're right next to each other, so we're going to be multiplying. Okay, so let's do a problem. Here's a parallelogram. It says find the area of a parallelogram. So we're going to take area equals base times height. Well, the base is 13 centimeters times the height is, well, it says right here that this diagonal line, or not, this dotted line is 5.8. That is our height. So we are going to take a calculator. Remember, you can use a calculator throughout this whole chapter, times 5.8, and we get 75.4. And the way that we label area again is, yep, units, and our units is centimeters in this case, squared. And so our answer is 75.4 or 75 and 4/10 centimeters squared or squared centimeters. Nice job. Let's do another one. So here is a parallelogram. Now this one they try to trick us. They try to trick us on this one. They try to trick us in two different ways. What I want you to notice is we have three numbers and we only need two. Remember, we're only multiplying base times height. So, and then they also try to trick us because notice this one's in feet and these other two are in inches. Well, how do we multiply two different units of measurement? Well, we can't. We can't multiply them the way that they are. We actually need to change them into the same measurement. So either we change the inches into feet or the feet into inches. Well, there's only one of them. And I think it would be easier in this case to change the feet to inches because how many inches are in 1 foot? 1 foot is 12 inches. So it's pretty easy to change that one to inches. So I think let's do that. Now we actually have a base. So let's put 12 times. Now which one of these numbers is the height? Remember, we're looking for the 90-degree angle, straight up and down line. It may be dotted and it may be filled in. Either way, we're looking for a line that's straight up and down that creates a 90-degree angle. And so the only number that does is the 8. So we're going to take 12 times 8, and 12 times 8 is 96. And then we're going to label it inches. We are not going to turn it back to feet. And we're going to put squared on it because we're finding the area. Whenever you multiply again, two units of measurement together, it creates that squared. And so that's why we label it with squared. Okay? Now, here's my next question. What shapes make up this parallelogram? Yeah, triangles. Nice job. And so a triangle is a three-sided polygon. And if you notice, it created two triangles, and that's going to be our next area that we're going to find. We're going to find the area of a triangle. And so you copied down this formula in your packet or in your vocabulary packet. So here's a triangle. Now, triangle is very similar to a parallelogram in the fact that, for one, a triangle is created from a parallelogram. And because of that, a triangle still has a base, just like a parallelogram, and it also has a height. And so what I want you to notice, when you separated this parallelogram into one triangle, how much space is that of a parallelogram? Yeah, isn't it half of this parallelogram? Excellent. So look at the formula. The formula is actually base times height, so that stays the same, but then we're taking a half of it. And it doesn't matter if I take a half of the whole area or if I just take, sometimes I want to take half of just the base or half of the height. It actually really doesn't matter as long as I'm taking a half one time. I got to take a half just once, okay? And so this formula is very similar to our parallelogram. It's just the fact that we're going to have to take a half of whatever area we find. So let's look at a triangle. We have, in this case, we have a base of 4 centimeters. And I want you to know the base is always the side that has the height that comes straight down to it. It's always the side that has the 90-degree angle, okay? And so if I am finding the area of this, basically what I'm doing is I'm taking base times the height, and then I got to take a half of it. How do I take a half of something? Yeah, I can divide by 2. I can even multiply by, what decimal is a half? 0.5. Okay, there are different ways to take a half of something. No matter which way you choose, you'll still get the same answer. And so let's actually do 4 times 6 is 24. And then if I'm going to take a half, I'm going to actually divide by 2. Because I think in my head I can divide 24 in 2 equal parts, and that part is 12. And so my answer, my area of this triangle is 12 centimeters, and I'm going to label it again with squared centimeters. Okay, how about this triangle? Look at this one. Just like a parallelogram, the height can be on the outside of it, because if that's the only place where we can get from the top all the way straight down, and then that's the place where we're going to start. And so this part is my height. This part over here, this solid line, is the base. And so to find it, I'm going to do a half. I'm going to actually do a different order, and I want you to see that no matter what, I can still get the same answer. Let's say, for instance, I don't want to multiply 10 times 14 and get a bigger number. I want to actually start off by taking a half of 10 or a half of 14. I can take a half of either one and then multiply it by 10. So let's take a half of 14. What's a half of 14, or 14 divided by 2? 7 times, and my other number is 10. And so I get an area of 70. Now I want you to see that I would still get the same area even if I did